Woohoo! Congratulations on making it to the end of the section. In this lesson, I'm going to do a quick code review of what we covered in the earlier lessons. So first of all, we came in, we set up our HTML, and then we also added in some styling. We tried to keep it to a minimal because, of course, we do want to focus on JavaScript. We created one main class, which was the brick, as well as the container, and then the score and the lives so that it shows up a little bit bigger on the screen. And we could have, of course, done that in JavaScript as well, so it would have taken quite a few lines. And the earlier lesson where we went through creating the element and applying all of the styling, it was a good exercise in applying styling, but it did take quite a bit of time. And as well, a lot of this is repetition. So once you start accessing the styling and updating the styling, then this is just like setting styling within a style sheet. The format is pretty much the same. The property values are the same. The property names are slightly different, so keep that in mind as well, that we don't have any spaces, we don't have any dashes, and this is all camel cased. So sometimes you do have to look up, and with editors like brackets, you're going to get a drop down when you do ball style and another dot, and you're going to see a drop down of the options that you have for the styling. So you can start typing it, and you generally be able to figure out what the style and how to adjust that style property. So everything you can do with CSS, you can do with JavaScript, and you can do it better with JavaScript, of course. So getting the container, creating the elements, so creating our main game elements, including the paddle, the ball, and then hiding them. We added in event listeners for the key presses to track the key presses. So this gives us an option to track multiple key presses at once. We could have done it as well that every time the key is pressed, then we take the action directly. But in this case, we chose to add an update to the paddle object where we were setting the value of left to right to true, and then on key up to false. So this is in case the user is holding the key down. We don't need to register it multiple times, and this is also leads to a smoother animation when you do it this way, because it's only looking for the object value, and it doesn't matter if you're pressing the key, letting off of the key, you're not going to have any type of choppy movement. And as soon as you let off the key, then it goes to false, and whatever animation frame it's on, then it's going to stop that action. We also added in one last one here, looking for the press of the up arrow, and that would launch the ball. You can also adjust this to other numbers, other key codes as well, and add that into the string. So checking to see for a number of different key codes. And the most important one here is that if player in play is false, then we're going to set it to true. And that's what that action is doing. And setting it to true initiated the ball movement and allowed us to move the ball around. We set up one main default object called player. So this is where all the player values go, and this is global, sitting on the global scope. So that gave us the ability to access it in any one of the functions and really easily access and update those values. Starting the game, so that was the main game function where when you hit the start game button, starts the game. So there's a bunch of variables that we had to set up. So everything player is player related. So we set all of those. We also set a default position for the ball. So in case we're starting the game again, we're setting the default position of that ball. And we also were handling it whenever we're adding it and landing it on the paddle. So we could potentially remove this, but let's keep this in case. But it probably isn't doing a whole lot right now because we did add that updated function. So next we set up all the variables for the player, set up the visuals, and then set the bricks. And this was dynamic, so we can create as many bricks as we want. And we created a function in order to handle that, so called it setup bricks. It takes one parameter, and that's the number of bricks that we need to create. And it builds out the calculations for where it's going to position the bricks. So positioning them in a grid-like fashion. So initially it centers them. So the X starting position is centered. It calculates how many 100 bricks it can place across the screen. And then it divides the remainder by 2. So that gives us the ability to center it. And then the starting position of Y. And every time we hit to the end of X and we increment X back to 0 to the start position, and then we also increment Y, so we get another row of bricks. And then whatever number of bricks we have, it will continuously to build out the rows. We do have one calculation here where we're checking to see and making sure that the width, the bricks row Y hasn't passed our center point of the application, because we don't want the bricks going all the way down, and we want that dynamic sizing for the screen So that's where we added in the ability to skip creating additional bricks. So once we hit a certain point, then we're not going to create any more bricks. We're just going to skip that. And the creation of the bricks. So this was relatively a simple part where, again, we're creating an element, applying some styles to it, and then appending it to the main container. So that took care of starting the game. We also have a function to update the score. So anytime the lives and the score need updating, we take the value that's contained within the player object and we apply it to the screen so that we can see it within the screen. And then we kick off our animation sequence, making a request animation frame, calling the function called update. And then this is where all the action happens and all the fun stuff happens, where we're checking to see if the game is over first. And if the game is not over, if it's in play, we get the paddle position and then we update the paddle position. We check to see if it's off screen and we can subtract to it. So we make sure that the boundaries are set for where we can subtract and where we can add to it. And then we update its visual position, its style properties, left properties. And then we also check to see if the ball is in play. So if the ball is waiting on the paddle, then we run the function waiting on the paddle. If the ball is moving, then we run the function move ball. And then after all of that is said and done, we relaunch the animation to have a nice smooth animation within update. So it continuously runs this block of code while the game is in play. We create a function waiting on paddle because there's a number of times that we would need to call to this. So what this does is this sets the ball position according to wherever the paddle position is. And that gave us the ability to kind of make it look like the ball was sitting on top of the paddle and we could move it across and around. And then once the player launches the ball again, then we'll just go back to moving the ball. We had some conditions to check to see if the ball falls off screen, and if it does, then the player loses a life. If the player is less than 0 lives, then the game is over. We have a function to run the game end, and we just reset the player lives to 0. We do an update of the score, so that visually representing the change in the lives. So anytime to change the lives or the score, you need to update it, so run score updater. And then we have a function called stopper, which is where we stop the ball from moving and we sit it on top of the paddle. So that's our function that handles that. End of game, so that shows the start game again, that option to restart the game. Gives us our score, sets the game over to true so that we're not running any more animation frames. We also hide the ball off the screen. We then get all of the bricks and we make sure that there's no bricks left. And there shouldn't be if you've run out of bricks, but this is just in case. And of course, we want to remove any bricks that might be existing that might interfere with the next round of the gameplay. So always a good idea to kind of make sure and you remove all of them out. So stopper, we already talked about that one, and that one runs the cancel animation frame, sets it on the paddle, and then visually sets it on the paddle, updates the ball direction, and updates the in play. We have our move ball, so this is where we've got some calculations where we get the ball's current position. So using the offset left and offset top, we get an X and Y position, and then we use those X and Y positions to make our calculations. We check to see if the ball if it's gone off screen in any way, and if it's at the edge of the screen, so that created our boundaries, gave us the ability to flip it. So multiplying anything by a -1 will flip it to a negative will become a positive will become a negative. So that's how we change direction, where we just multiply the direction by 1. So whatever the value is within this array, we're just going to multiply it by 1. And this also gave us the flexibility to change the speed of the ball and the angle of the ball and all of that. If the ball runs off the screen, that means that we lost a life, and we run the fall off function, which we've covered. And then we also do the same thing for the X, the horizontal coordinates. So we make sure that if the ball is running off the horizontal right side or the left side, then we just change the direction of the ball. So 0 was ball direction of the value of how it moves horizontally, and ball direction 1 is the one that takes care of the vertical moving. We also check to see if there's a collision with the paddle, and if there is a collision at the paddle, then we console log out hit. We can remove that. We update the ball direction, and then we also flip the horizontal direction as well. we go through all of the bricks and we check to see if bricks is at 0. And if it is 0, then we stop the ball from moving, we set it back on the paddle, and then we set up a new set of bricks so the player can continuously play, score more until they actually lose all of their lives. The game's not going to end. We loop through all of the bricks that we've selected within the node list. We check to see if there's collision with the ball. If there is collision with the ball, that means that the ball hit one of the bricks. So we need to update the player's score, remove the brick from the visible area, and then update and do the score updater. And over here is where we're changing the ball's direction so that if it's going up, it'll start going down and so on. And then we make an update for the player position of the ball, depending on what we've done here within the conditions. And then lastly, we set the ball style properties to match what the ball position, the new ball position is of X and Y. I hope you had an opportunity to try out some of the code, extend on the functionality that we've covered and make the game even better, enhance the gameplay, update some of the styling, make it look better, really customize the game functionality. There's a lot of directions to go from here. Thanks again for taking the course and for taking the section. If you have any questions or comments or need clarity on any of the topics that have been covered, I'm always happy to help within the Q&A section. Please let me know, and I'll see you in the next one.